Welcome all. As a part of our question series for GATE 2023, and today I'm going to discuss questions on machine design. So I tried my level best to include some good questions. Straight away, let us get into questions. Look at the first question. Observe here. Yes. Now, a given steel has identical yield strength of 700 megapascal in uniaxial tension and compression. Okay. So I repeat, sirs. It has uniaxial. One second, please. Which color do you want me to take? Let's try this. This is good. Okay, chalo. It has identical yield stress in tension and compression. It means the yield stress is 700 megapascal both in tension and compression. No problem. I'll take some other color. Black is good. Okay. Okay. If the steel is subjected to pure shear stress such that three principal stresses are sigma 1 is given as sigma 2 is given as 0, and sigma 2 is given as 0, and sigma 3 is minus. What does minus indicate? Compressive. Okay. Then the stress sigma for the initiation of yielding in the steel as per von Mises theory. Okay, let's try to solve this question. It's a simple first question. As per von Mises theory, you know the yield criterion is sigma 1 square plus sigma 2 square in a 3D. Sigma 3 square minus sigma 1 sigma 2 minus sigma 2 sigma 3 minus sigma 3 sigma 1, and that should be less than equal to sigma yield square. This is our von Mises criterion. And this you call it as working stress. We call it as working stress. And already in the problem, sigma 2 is given as 0. So sigma 2 is 0. 0 square is 0. Sigma 2 is 0. Sigma 2 is 0. So this will be 0. Sigma 2 is 0. 0 into something 0. 0 into something. So we are left with sigma 1 square plus sigma 3 square minus sigma 3 sigma 1 should be less than or equal to sigma yield square. Sigma 1 is sigma and sigma 3 is also sigma. So minus sigma, I'm sorry. Minus sigma 3 is minus sigma into sigma 1 is sigma. I have just substituted. And that should be less than or equal to sigma yield is 700. So it is 700 square. So minus of minus plus this square plus sigma square, sigma square, sigma square. This is 3 sigma square is less than or equal to 700 square. Is less than or equal to 700 square. Wonderful, sirs. So sigma square is less than or equal to 700 by 3, 700 square by 3, 700 square by 3, or sigma should be less than or equal to 700 by root 3. So what is 700 by root 3? I think it is 404. Yes, let me check. 700 by root 3, 404. Yes. So sigma is less than or equal to 404 megapascal. It means when sigma reaches 400, then yielding starts. If it is less than 404, see, if sigma reaches 404, then yielding starts. If sigma is less than 404, there is no yielding. But what is he saying? The stress sigma for the initiation of plastic yielding. So if the yielding is to be initiated, the stress value of sigma should reach 404 megapascal or above. Okay, so this is the first question, which is a very simple, straightforward question. Let's go to the next question. Now, the SN curve for a steel is shown in the figure. Okay, the stress ratio, you know that stress ratio is minimum stress to the maximum stress, and that is given in the problem as 0.8. So I can write the minimum stress as minus 0.8 sigma max. I can write the minimum stress as minus 0.8 sigma max. And one more thing, my dear students, if you observe clearly, one second please, let me take some other color. Look at, please. If you see the left side, this is finite life. And if you see the right side, it can go for infinite cycles. So please look at, for infinite life, what is the stress? 300. If it is less than 300 or 300, it can go for infinite number of cycles. But if it is more than this, for example, say it is 400. So if the stress is 400, the life is only these many cycles, these many cycles. But what is he asking? The maximum stress for infinite fatigue life. He is asking the maximum value of stress for infinite life. Means he is focusing on this. This is all infinite. So this is the one. So observe here. Stress amplitude is given on y-axis. So what is stress amplitude? Corresponding to this infinite life, it is 300. So the stress amplitude is nothing but maximum stress minus minimum stress by 2. And this is also known as variable stress or stress amplitude, which is nothing but maximum stress minus minimum stress by 2. And that is given to us as how much? It is 300. So it is 300. Wonderful, sirs. So therefore, sigma maximum minus sigma minimum is equal to 600, 300, 600. So he is asking the value of maximum stress. So maximum stress minus minimum. What is minimum? It is minus 0.8 sigma max. I'm just substituting minimum as minus 0.8, and that is equal to 600. So minus of minus is plus. 1 plus 0.8 is 1.8 sigma max, and that is equal to 600. And he is asking sigma max. And what is sigma max? It is 600 by 1.8. Let me check what is 600 by 1.8. And that is 333. So therefore, the maximum stress is given by 333.3 megapascal. All these stresses are in megapascal. I think he's also asking in megapascal because all these are given in megapascal. So therefore, it is 333.3 megapascal. Is it okay? Nearest integer, that is 333. 333 is the answer. Is it okay? Right. No problem at all. So slowly I'll increase the toughness of questions. Take this question. Now see the question. Beach marks are commonly observed on the fractured surface of metals after. My dear students, beach marks are something like this. Here the crack is initiated and the crack is propagated something like this. These are beach marks, and these marks are found in fatigue test. These beach marks are found in fatigue test. So I think I had explained in my regular class also, beach marks are found in fatigue test. So I had already explained how the crack is initiated and how that vibrational energy is converted into thermal energy and how that is weakening the material, how the crack is propagated. All these I had discussed in my regular plus classes on Unacademy in our machine design course. Okay, so beach marks are something like this. So why do we call it as beach marks? Because in like on beaches you'll be seeing when wind blows, you'll be seeing something like this, marks on the sand, something like this. So therefore it is something analogy to that. Therefore they have given the word beach marks. So you find, so this is the beginning of crack and slowly it spreads, and these beach marks are found in fatigue test. Okay, next. Before we go to this question, a second. Okay, first take this question. Okay, a second. I'll do all questions. Don't worry. All are good questions. Let's do all questions. A simple question. A multi-disc clutch has 4 discs. Sorry. Where is that? 4 discs. 1 second, please. 4 discs. 4 steel discs, 3 bronze. How many total are there? There are 7. So number of contacting surfaces is given by N1 plus N2 minus 1. So here the number of contacting surfaces is given by, already this equation I have derived in class. So therefore it is 4 plus 3 minus 1. So N is equal to number of contacting surfaces is 6. Very good. And the outside and inside diameters are, the outside diameter is 250 mm and the inside diameter is 180 mm. And the coefficient of friction is 0.3 and the axial force is 400 Newton. Dekho, axial force is 400. What is the power that is transmitted at a speed of how much? 1000 RPM. No problem at all. And he said, assume uniform theory. When I was discussing in your regular classes, I have given what is uniform wear theory, why PR is constant in uniform wear theory, and when is uniform pressure theory used, under what conditions uniform wear theory is used. All these I had explained. So the torque transmitted is given by N mu W. RO plus RI by 2. And this is the torque for uniform wear conditions. If it is uniform pressure conditions, it will be N mu 2 by 3 W RO cube minus RI cube by RO square minus RI square. That is for uniform pressure. But in the present problem, he is saying uniform wear. So let's calculate torque in Newton meter. So torque is equal to, how many contacting surfaces are there? 6. What is the coefficient of friction given? 0.3. And the actual load that is required for engagement is 400. And please note down that RO is 125 mm because the diameter is given as 250 and RI is 180 by 290 mm. Great. So therefore, you will get this as 125 plus 90 by 2, but you should be very cautious. This has no unit, this has no unit, this is Newton and this is mm. So you will get the torque in Newton mm. You will get the torque in Newton mm, and that is 77.4 into 10 power 3 Newton mm. Okay. But I want torque in Newton meter. So therefore, 10 power 3 mm is 1000 mm is 1 meter. So it is 77.4 Newton meter. Now I want power. It's as simple as that. So power is equal to torque into omega is 2 pi n by 60. So therefore, power is equal to, what is the torque? 77.4 into 2 pi and the speed is 1000 by 60. And if I am calculating, I am getting the value as 8105 watt or 8.1 kilowatt. He is asking the answer in kilowatt. So in kilowatt, it is 8.1 is the answer. 8.1 is the answer. So slowly we'll increase the toughness. And now this is a very good question. Please read the question. This is a very good question and please read the question. There are two designs proposed for a shaft. This is for the design of shaft. Okay, two shafts of length L. So both shafts have same length. That is L1 is equal to L2 is equal to L, that is given. Okay, and torque carrying capacity is T. Matlab, the torque is also T. So the first case torque, second case torque, and it is T. Okay, no problem. And so actually he has given 2 as 2. I am taking that 2 as 2. Anyway, I wrote here 2, no problem at all. So I wrote here as 2. So no problem. It is actually 2. Okay, no problem. Right. Now, first one is a solid shaft. Look at carefully. First one, it is a solid shaft. And second one is thin walled shaft. Thin walled. Okay, no problem at all. And its average diameter is 40 and its diameter is 30. No problem. The first one has a diameter of 30 and the second one has 40. No problem at all. Thickness of the wall is designed to be determined such that the maximum shear stress is same in both. It means tau max in 1 is equal to tau max in 2. This is also given. Any other data given? Lengths are same. Okay. And torque is also same. And material is also same. No problem. What is the ratio of mass of first shaft to the mass of second shaft? Very good question. Now, let me repeat, sirs. There are two shafts. One is a solid shaft of 30 mm diameter. Other is a thin walled shaft of 40 mm diameter. Now, what is he asking? Both are of same length. Both are subjected to same twisting moment torque. And both are made of same material. So, maximum shear stress is same. And what is he asking? What is the ratio of mass of 1 to the mass of 2? Let's try to do this. So in order to find out masses, I'll tell you one thing clearly. Density is equal to mass over volume. So mass is equal to density into volume. But as they are made of same material, my dear students, as they are made of same material, my density will be same. So mass is directly proportional to volume. Can I write volume as area into length? Can I write volume as area into length? Definitely I can write. And please note on that both are made of same length. So length is also same. So mass is proportional to area. He is asking mass of 1 to mass of 2. That means simply you have to calculate area of 1 by area of 2. That's it. Nothing more than that. Just you have to find out ratios of areas. Cool. Now, the first one is solid shaft of diameter 30 mm. So what is the area of first one? I will write this as pi by 4 d square. This is the area first. Area first. Now area of second. Look at, my dear students. This is a hollow shaft. Sorry, thin walled shaft. I do not know the thickness, and the mean radius is given as 40. So if you cut it and open, it will be something like this. If you cut it and open, it will be something like this. You cut it and open. So the thickness is t, and what is the length of this circumference? What is the circumference? It is 2 pi r. So therefore it is 2 pi r. So what is the area? Very simple, 2 pi r into t. So its area is, second area is 2 pi r second. Please do not get confused with this and this. The first one, 2 pi r2 into t. 2 pi r2 into t. This radius, diameter is given as 40. Observe, do not get confused. The diameter of second is given as 40. So what will be the radius? It is 20. Be careful. So look at 2 pi r2 into t. So A2 can be written as 2 pi r2 into t. R2 is already known, and it is 40 by 2, that is 20 mm. The only unknown is thickness. If the thickness is calculated, the problem is solved. Very good. Then how do I calculate thickness? Wait. You know that T by J is equal to tau by R. Let us take solid shaft. Solid shaft. For solid shaft, what is J? Pi by 32 d power 4. Tau by, this is a maximum shear stress. What is R? D by 2. So this 2, this is gone. This d cube. This 16 will go to the top. So the maximum shear stress is 16t by pi d cube. This is the maximum shear stress for solid. And what about in circular cylinder? You know that again it is subject to torsion. T by J is equal to tau by R. Wait. So tau is equal to TR by J. And can you give me what? T is same in both the cases. R. Okay. But this is second radius. Please note down that it is second radius. Second one. Don't get confused with this R and that R. ये first वाला है sir. ये first वाला. This is solid shaft. Solid means first. Okay. Now stop. What is the polar moment of inertia of a thin cylindrical vessel? Thin circular shaft. 2 pi r cube t. If I want, I can derive, but please remember, in many applications we find this. For a thin circular shaft, the polar moment of thin, I use the word thin, 2 pi r cube t. So therefore, J is 2 pi r cube t. Why I am writing 2? Because second one is thin one. So therefore, the maximum shear stress is given by T by 2 pi r2 square t. Ek second ruko. This R2 is gone. So it will be T by 2 pi R2 square T. But clearly he said this maximum shear stress is same. He only said equate. 16T by pi D1 cube is equal to T by 2 pi R2 square T. So pi is gone. So T is gone. So if I want T. So T will be, you bring T to this side. 16 into 2 is 32. This is D1 cube. I repeat, sirs. You bring D1 to this side, T to this side. So T is 16 into 2 is 32 R2 square. Wonderful, sirs. So I got T as D1 cube by 32. So I got T as, एक second please. Let me erase. यहाँ थोड़ा erase करेंगे, sirs. We'll use this space. Don't worry. I got T as D1 cube by 32 R2 square. So diameter of first T is 30 by 32. Diameter of second is 40, but here we have radius, so it is 20 square. Let me check, sirs. Let me check. So therefore, 30 cube divided by 32 divided by 400. And I'm getting this as 2.11 mm. Now it is very simple. My dear students. Let's observe here. Ek second ruko. Just wait for a while. Now I want the mass ratio. If you want mass ratio, it will be A1 by A2. A1 pi by 430 square by A2 2 pi R2. R2 is 20 and the thickness is 2.11. This pi is gone. Let me check. 900 by 8. 160 by 2.11. I'm getting this as 2.67. So the mass ratio is, let's check whether that option is there or not. Yes, it is 2.67. I got, so this is the right answer. This is a good question, sirs. Chalo, let's go to the next question. Ye ho gaya. This is over. This is also over. Now take this question. Take the next question. I request you to read first. A gas cylinder, closed thin wall. Again, it is a thin wall pressure vessel, but it is closed. Whenever it is closed, there is longitudinal stress and it is subjected to internal pressure. So please note down that if the cylinder is not closed, you will not have longitudinal stress. You will have only circumferential stress, but it is a closed one. Whenever it is a closed one, there will be longitudinal and it is subjected to internal pressure. There will be circumferential. So you know that you have studied in thin pressure vessels. The circumferential or hoop stress sigma 1 is given by PD by 2T. And sigma 2, that is longitudinal stress, is given by PD by 4T. All these I had derived in a beautiful way with models I have derived in our regular plus unacademic classes. Okay. And you know what is he asking? And the material used for the manufacturing has a failure stress of, this is the failure stress, maximum stress, or we can write the failure stress is given as 260 megapascal. No problem at all. Assuming von Mises criterion, the factor of safety is, he is asking what is the factor of safety, assuming von Mises criterion. So he is asking factor of safety. Let's try to do. And as per von Mises theory, the working stress is given by sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. This is my working stress. This is my working stress. This is actually under root. I have to take. एक second please. Sorry. नहीं. एक second. Okay. पूरा रिलेस करेंगे सर. 1 second please. I'll explain. Don't worry. The working stress is given by, as per von Mises theory, is given by under root of sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. I have given this very clearly. The working stress is given by this. Very good. Now let's calculate sigma 1. And sigma 1 is equal to P. What is the pressure? Where is that? 0.5. Look at, if this is in megapascal, if this pressure is in megapascal, if this pressure is in megapascal, this will also be in megapascal. P by 2. And both should be in same dimension, because dimensionless, P same as sigma. So D, what is D? 30 centimeter. And T is 1 mm. The thickness is 1 mm and the diameter is 30. Both are not in same. So convert centimeter to mm. So 30 centimeter is 300 mm and the thickness is 1. I repeat, I have converted from centimeter to mm. This also mm. So you will get sigma 1 as, how much is this? ये कितना आ रहा है sir? पता नहीं यार, 150 into half, 75 I think. Yes, 75. So what will be sigma 2? PD by 40. अरे यार इधर देखो, in denominator you have 2, in denominator you have 4. So with 2 you have calculated 75. With 4 it will be, divided with 2, it will be 37.5. I repeat sir, it will be 37.5. So therefore, the working stress is given by sigma 1 square. What is sigma 1? 75 square. Sigma 2 is 37.5 square. Minus sigma 1 into sigma 2, and I will calculate this. So let me check what is the working stress, and therefore the working stress is 75 square plus 37.5 square minus 75 into 37.5, and this is the working stress, that is 64.9 is the working stress. And what is factor of safety? It is nothing but the maximum. Failure is the maximum by working. Failure is the maximum. So the factor of safety is maximum stress of the material by allowable stress, that is maximum by working stress. What is the working stress? 64.9. So the maximum is 260 and the working is 64.9. So this is into 260. So I am getting this as 4. I am getting this value as 4. Is it there? Yes, it is there. Absolutely, it is there. Very good, sirs. अब थोड़ा tough question के तरफ जाएंगे. Take this question. Take this question. This is a very good question, sirs. It is on minus rule. चलो check करते हैं. the fatigue behavior of an aluminum alloy in SN plot is shown here. A piston rod made of this metal is subjected to 1000 cycles at 420 megapascal. Look at carefully. For 420 megapascal, what is the failure's number of cycles? So look at carefully. Look at carefully. For 420 megapascal, what is the number of cycles that it can sustain? So look at carefully. If a member is subjected to a stress of 400, it will sustain a maximum of 2000 because this is load life relationship. Look at this is 420. This is clearly it is given. This is 400 and this is 420. For 420, the number of cycles is 2000. Means the number of cycles given. Let me take this. The number of cycles, one I'll take it as 420 and that is 2000. Very good. Next is what? Next is 300. So for 300, what is the number of cycles that it can sustain before failure? Before failure, what is the number of cycles? It is 5000. So it is 5000. Physically, what does it mean, sir? It means, I repeat, it means if a member is subjected to a stress of 420, it will run for 2000 cycles and after that it fails. If a member is subjected to 300 megapascal, it will run for 5000 cycles and it fails. But please note down that, is it running, and one more, remaining fatigue life is for a stress of 250. So baki ka 250 hai, remaining is 250. Now, and for 250, what is the failure number of cycles? For 250, clearly it is given. This is 200 and this is 250. For 250, it is 88. So therefore, I read this as 8800. This is for 250 megapascal. But please note down that. Is it running for 2000 cycles for under 420 load? Under 420 load, it is running only for 1000 cycles. Means it is running only for 1000 cycles. What does it mean? If it runs at a stress of 450 for 2000 cycles, there is no life, it will fail. But it is not running for 2000 cycles at a stress of 420. It is running only for 1000 cycles, means some more life is left. And some more life is spent under 300 Newton. And how much life is spent under 300 megapascal? Sorry, 300 megapascal, 1000 cycles. It means for 300 megapascal, it is 1000 cycles. I think it is 1000, given 1000. And he is asking, how many cycles will it execute under load of 250 before failure? Look at the remaining fatigue life at a stress of 250 means my member is subjected to a different stresses during its life. First, it is subjected to 420 and under 420, it is running for 1000 cycles. Next, 300 megapascal and it is running for 1000 cycles. And remaining life at 250 megapascal, it is running. And he is asking for, before it fails completely, for how many cycles it is running under 250 megapascal. Look at, if the life under some stress is n, if the life under some stress is n, what is the fraction for one cycle? If the total life is n cycles, how much time it has spent for one cycle? It's something like this. You are living for 100 years. If you live for 1 year, how much part of your life you have spent? 1 by 100. I repeat, sirs. You are living for 100 years. Let us say this 100 years. Now you have completed 1 year. So how much part of life you have covered? 1 by n, 1 by 100. 1 by 100. Something like 1 by n. Now if you live for 30 years, for 1 year it is 1 by 100. If you live for 30 years, it will be 30 by 100. Similarly, for 1 year cycle, it is 1 by n. For n cycle, it is n by n. This much fraction is for a particular stress. And sum of the fraction is always 1. So therefore, this much fraction is for how much, sir? 420. And this much fraction is for 300. And this much fraction is for remaining 250. And some, if you are cutting apples, this fraction, total fraction should be 1. So I repeat, sirs, it's something like this, my dear students. Some part of your life is undergoing in a tough phase. Some part is undergoing in an easy manner. So all fractions put together, it is 100 by 100, that is 1. Very good, sirs. This I had explained very clearly and I have derived also. So N1, it is 1000 by capital N1, it is 2000. N2, it is 1000 divided by 5000 plus N3, I do not know, by capital N3 is 8800, and that should be equal to 1. And what is small n3? It is the number of cycles that my component is spending under a stress of 250 megapascal. Let me check, sir. This is half and this is 1 by 2, I think. 1 by 2 means kitna aa raha hai, sir, ye? 1 by 5 is 0.2, 0.7. So therefore this is 0.3. 8800 into 0.3. So I'm getting this number of cycles as 2640. It means, physically you try to understand. So the answer is 2640. What does it mean? It means 1000 cycles is spent at 450 megapascal. 1000 cycles is spent at 300 megapascal, and 2640 cycles is spent at 250 megapascal. That is the total life of this. And this is known as Miner's rule or cumulative fatigue design. We call it as cumulative design. We'll move to the next one. Next one. Take this question. Again, a good question. Again, a good question. A 0.5 meter long, thin walled circular vessel. I repeat, sirs. 0.5. 0.5 meter. Length is half meter. Thin walled. And he has highlighted also. Circular shaft of radius 2 meter. The radius of the shaft is 2 meter. Okay, I'll write here. The radius is 2 centimeter. I'm sorry, sir, 2 centimeter. How can it be 2 meter? Okay, is to be designed for an axial load of 7.4. The axial load, let me write it as F. The axial load is 7.4 kilonewton. So the axial load is 7.4 into 10 power 3 Newton. No problem. And a torque of 148. There is torque also simultaneous. There is axial load and there is a torque of 148 Newton meter. And the torque is 148 Newton meter. No problem at all. Applied as shown. The allowable shear stress under, look at the allowable stress, not shear stress. The allowable stress under uniaxial tension. Uniaxial tension is 100 megapascal. The maximum under the maximum tensile load. The maximum tensile under uniaxial load is given as 100 megapascal. The maximum load is 100 megapascal. Okay, where is that? Is 100 megapascal. Using maximum principal stress theory criterion, the minimum thickness of the shaft that so that it doesn't fail is in mm he is asking. Okay, no problem at all. No problem. And the radius is given as 2 centimeter. Let me solve this. It is subjected to tensile and due to torque shear. So it is subject, it's something like this. If you take a small element, look at carefully, and there is in the small thickness, there is tensile and there is shear. If you take the element, there is tensile stress and there is shear. There is shear, and therefore, if it is anti-clockwise, there will be complementary shear in clockwise direction, anti and clockwise. Right. Let's proceed, sirs. So let's calculate the tensile stress, which is in x direction. So it is total force by area. So the tensile stress is given by F. What is F? 7.4 into 10 power 3, and it is a thin shell, sirs. It is a thin shell. What is the area? 2 pi RT. 2 pi, this is the area which is resisting the axial load. 2 pi R into T. It is 2 pi, and the radius is, okay, I'll write it as 20. mm में convert करेंगे, sir. We'll convert everything in mm. 2 centimeter is 20 mm, and the thickness is given, I think. अच्छा, वही तो calculate करना है. That is the value to be calculated. So look at, let me take this in mm. This is also in mm. This is Newton per mm square. So therefore, 7.4 into 1 exponent 3 by 2 by and this is sigma x is equal to 58.88 by t. Now let's calculate the torque. Anyone? You know that T, it is torsion. It is torsion. T by J is equal to tau by R. And what is the torque? And one more thing, let's keep it in mm, Newton mm. So therefore 148 into 10 power 3. For a thin shell, what is the polar moment of inertia? 2 pi r cube t. So this J is 2 pi r cube t. 2 pi r. What is the radius? 20 mm. And the thickness we don't know. Should be equal to tau by r. What is r? R is 20 mm. So this 20 with square it is gone. So tau will be equal to 148 into 10 power 3 by 2 pi into 20 square into t. Let me check. 148 into 1 exponent 3. So tau is equal to 58.8 by t. Oh my god, this is also 58.88. Now, please observe here, uniaxial, he is asking us to use maximum principal stress theory. So you tell me, a member is subjected to sigma x and tau, anti-clockwise, and this is clockwise, tau. Okay, so what is the maximum principal stress? It is sigma x plus sigma y by 2 plus under root sigma x minus sigma y by 2 whole square plus tau square. This is the maximum principal stress. But sigma y is 0. There is no sigma y. There is only sigma x. So sigma y is 0. So therefore, sigma 1 is equal to sigma x by 2 plus under root of sigma x by 2 whole square plus tau square. Excellent. So already the maximum principal stress is given. Already under uniaxial loading, what is the maximum tensile? Under uniaxial loading, already the sigma 1 is given. Already maximum tensile load is given. Under uniaxial loading, maximum tensile load, this is given. And this is given as 100 megapascal. Sigma x, what is sigma x? 58.88 by t. That is sigma x by 2 plus sigma x by 2, 58.88 by t, but there is 2 also, by t whole square, plus tau square, 58.8 by t ka whole square, and everything is known except t. Everything is known except t. Let me check what is the value of t, sirs. I am getting the answer as 0.952 mm. Let me check. 0.952 mm. Very good. Now, dear students, एक second रुको. If I put 0.952, do you think the answer is correct? But I got that 0.952. If I put 0.952, do you think the answer is correct? Do you think the answer is correct? It is wrong. It is out of the range because he said, what is that? Using maximum thickness rounded off to the nearest integer. So for 0.952, which one is the nearest integer? It is 1 mm. So therefore, and if you put 0.952, it will not be in the range because he said nearest integer, it will not be in the range. That's why I said read instructions properly. Even though you have calculated, everything is correct. But unfortunately, you have not seen rounded off to the nearest integer. That's why it is wrong. So therefore, it's not 0.952. 0.952 is the thickness, but he said rounded off to the nearest integer. The nearest integer for 0.952 is 1. So the answer is 1. So he has given without range. So we'll see the next series immediately after this. So thank you, my dear students. And I'll do some more questions on machine design. Thank you.